Welcome back to my channel. In today's class, we are going to study about empirical formula. Empirical formula is one of the topic of the chapter 1, and that one is some basic concepts of chemistry. Okay, so let's start with some empirical formula. Now before starting with empirical formula, let me give you some examples. So as we know that the formula of water is H2O, formula of carbon dioxide is CO2, formula of ammonia gas, and that one is NH3. So when we will see the formula of water as well as carbon dioxide or ammonia, what can we observe? We observe that these all formulas are showing how many number of atoms are there in that particular formula. How? Like see, in this one 2 H atoms and 1 O atom. Okay, here also it is 2 oxygen atoms and 1 carbon atom. At the similarly in ammonia also 1 nitrogen atom and 3 hydrogen atoms. So in these all formulas we can observe that there are these formulas, they have given the exact number of atoms present in that particular molecule of a compound. So, and such type of formulas are actually known as molecular formulas. They are known as molecular formulas. So molecular formulas means what? Molecular formulas, it means the formulas in which we are giving the exact number of atoms present in molecule of compound. So here we can easily see that yes, how many atoms and how many molecules are there, easily we can see. But if I want to discuss about only the ratio of the atoms present in that molecule, then how we are going to show that I am explaining with the help of empirical formula. Okay, so these all are known as a molecular formulas. Now let me give you a few more examples to understand molecular formula and empirical formula. Okay, so if I have a formula of glucose, everybody knows the formula of glucose, yes or no? Okay, then let's see. So formula of glucose is C6H12O6. This is the formula of glucose, and we can say that yes, this is the molecular formula of glucose. Why I am saying it as a molecular formula? Because it is showing all the exact number of atoms present in that molecule. But if I want to see, if I want to take a simple ratio of it, if I want to take the simple whole ratio, then I can get it as like C1, H2 and O1, or simply I can write it as a CH2O, and this is known as empirical formula. This is known as empirical formula. Similarly, we can take an example of H2O2 also. What is H2O2? H2O2 is what? It is a hydrogen peroxide. So in hydrogen peroxide, this is the molecular formula. So what would be the empirical formula of it? Empirical formula, it means simplest whole number ratio, and that would be H and O. This will be the empirical formula, and in this way we can define what is empirical formula. Okay, let me write the definition of empirical formula. I hope you all understood after observing all the examples. Okay, now let's see what do you mean by empirical formula. So empirical formula, it can be defined as simple whole number ratio of atoms present in a molecule of a compound. So easily, as we have written both the formulas here, empirical formula as well as molecular formula. So easily we can understand what is empirical formula and what is molecular formula. So empirical formula means what? Empirical formula is that formula in which we are taking the simple whole number ratio. What we are taking? Simple whole number ratio of the atoms, whereas this one molecular formula is it means exact number of atoms we are taking. Now where we are using it? In class 11th, in chapter 1 specifically, we need to identify, we need to find out the empirical formula when the percentage has been given. For example, if I'll say that in a nature this carbon is present in 65 percentage, oxygen is present in 28, so and one more sulfur is present in 22. So when we will have all this percentage, then we can derive the formula of that particular sample with the help of few steps. So for that purpose we have to calculate, or and we need to study the calculation of empirical formula or molecular formula. Okay, so let's start with some questions. Okay, before starting with question, let me tell you the relation between molecular formula and empirical formula. What is that relation? Let's see. Molecular formula, in short we can say it as a MF. MF is equal to N into empirical formula, right? MF into empirical formula. This is the relation between molecular formula and empirical formula. Now the question is that how to calculate value of N. How we will come to know? We will be calculating value of N with the help of one more formula. And what is that formula? Let's write. As we can write this one way also, or we can write in this, that is the molecular formula mass. Molecular formula mass upon empirical formula mass. Empirical formula mass. Empirical formula mass. Now let's see how I can calculate value of N and how we can calculate the molecular formula and empirical formula. So here I'll be giving you one example, and that example is of benzene. Let's see. Now if I have example of benzene, so how can I write? As we know that what is the formula of benzene in class 10th, you all have studied, that is C6H6. So this would be the molecular formula or empirical formula? This would be the molecular formula. Why? Because exact number of atoms are we can see the exact number of atoms. Now let's see what is the empirical formula of empirical formula. Empirical formula of it is CNH, simplest whole number ratio. Now if I want to calculate the value of N, or this can be the relation. So how I will calculate the value of N? First of all, I will be writing molecular formula mass upon empirical formula mass. So first molecular formula is this one. We can calculate its empirical, we can calculate its molecular formula mass. How we are going to calculate? C6H6, it means 12 into 6 plus 1 into 6, and as we know 72 plus 6, it means 78 U. So molecular formula mass of C6H6 is 78. And what is the empirical formula mass? Let's calculate for CH also. C is 12 plus 1, so it would be 13 U. So let's write it as a 13, and when you will calculate it, we can easily get the value of 6. So in this way we can calculate value of N factor in when we are correlating molecular formula mass and empirical formula mass. Sometimes in the question also they will ask you to calculate value of N. So at that time we can utilize this relation and we can calculate. Students, I hope you all are understanding what I am explaining here. Okay, now let's start with one of the numerical. Okay students, so we have this numerical with us, and they are in this numerical they asked us to calculate empirical formula of the salt. Now let's read the numerical first, and in this numerical what they have asked, an inorganic salt gave the following percentage composition, and they have given the percentage composition of sodium. This we can write it as a percent, 29.11%. Here S is as a 40.51%, O is as a 30.38%, and they asked you that calculate the empirical formula of the salt. So when we will solve this question, while solving this question we will be solving this question in a tabular form. Okay, so what all columns we are going to for every question you can make this as a table and then you can solve. So first what you need to write, try to understand properly. I am taking it very step by step. So first step is always write all the elements present. Got it? So first what I need to write, all the elements present. So what all elements are there? First one is sodium, so I will be putting here as a sodium. Second one is S, so I will be writing it as a S. And third one is O, so I will be writing it as a O. Understood the first step? Now second step. In second step we will be writing here the percentage which has been given. So the percentage given is it is 29.11, second one is 40.51, and third one is 30.38. Percentage is also written. Now next one we will be writing atomic mass. What we are going to write? We will be writing atomic mass of element. Now as we know that what is the atomic mass of sodium? Atomic mass of sodium is atomic mass of sodium, and atomic mass of sodium is 23. Okay, and atomic mass of sulfur is 32. Atomic mass of oxygen is 16. So I hope you understood all the three steps. First step is writing elements, second step is writing percentage, and then third step is writing its atomic mass. Now let's see next what we need to do. Then we will be calculating in the next column, we will be calculating as moles of the element. Here what we are going to calculate? We will be calculating moles of particular element. And how can we calculate moles of particular element? Here I am telling, first of all write down the percentage upon 23, percentage upon atomic mass. Here also we will be writing given mass, that is percentage upon atomic mass. Here also I will be writing the same, 30 upon 38 upon 16, 30.38 upon 16. So what I did, I wrote all the percentage first and then atomic mass, and when I will be solving this value, you need to solve this value and always be in a habit of solving this value up to 1 or 2 digit after decimal, and we can get here as a value as 1.66. Okay, here also we can get this value as 1.68. You all will be calculating and then writing. Here we can get this value as 1.8. We can get this value as a 1.8. Okay, so after solving this, either 1 digit or 2 digit you can solve. So then the next step is to calculate simple moles ratio. Next one, what we need to calculate? Moles ratio. And how we are calculating? Let's see. We are calculating it as let's find out the smallest value. Smallest value is 1.6, so I will be writing it as a 1.66 upon 1.6. Here also 1.66 upon 1.66. Here also I will be writing 1.8 upon 1.6. When you will calculate this answer, you will be getting answer here as a 1. Here is also 1, and then when you will calculate it properly, you will be getting answer as 1.5. 1.5. So here what we want? We want moles ratio. Okay, understanding or not? After getting it into mole ratio, see student, here always we should get a whole number, but in case if we are not getting the whole number, what we can do? We can convert this value into whole number. How I am going to convert it into whole number? Let's see. If I'll multiply this value, that is 1.5 into 2, then it becomes 3 and I can get the whole number. Similarly, this same 2 value I'll be multiplying by this one. As the math says, if you are doing in this way, so easily we can get the value of it. And in this way, we got this as a whole number ratio. Now finally we can write the answer for this as what we need to write. We need to write it as a empirical formula. So I'll be writing its empirical formula by after getting the answer. So empirical formula is, here we will write empirical formula. And what is empirical formula? See how I'll calculate. First of all, I'll be seeing this value. Yes, Na. In the Na line, what I can get? 2. So I'll be writing here as Na2. Here is S. So it becomes S2. And next one is O. So I'll be getting answer it as a O3. And this is the empirical formula of that particular salt. One more time I am explaining that how we need to solve. Please listen carefully. First of all, whenever you will read the question, make this type of table, and then in the first column always write the elements those are present there. Then in the second column we are going to write the percentage of it. Okay, then after writing all the percentage which has been given in the question, then we need to write atomic masses. Sometimes atomic masses may be given in the question or may not be. So we need to by heart atomic masses. If any difficult element is there, definitely they will be giving. Otherwise, for simple elements, we need to by heart. So we wrote all the atomic masses. After writing all the atomic masses, what we did? We calculated moles of the element. How to calculate? Percentage upon atomic mass, percentage upon atomic mass, percentage upon atomic mass. Then we got some values. After getting moles values, we calculated moles ratio. How calculated moles ratio? First of all, identify the smallest mole value, and the smallest mole value, as soon as you will get, divide that value with everyone, and then we'll be getting this. Now in place of this, consider that if I got 2 here, so no need to make it as a whole because all the whole numbers are there. But as we didn't get whole number, so that's why we have multiplied with a simple integer to get the whole number. So student, I hope you understood this empirical formula, and in NCERT there are given some questions. Try to solve all the questions, and if you have any doubt, so feel free to ask, or you can write it in the comment section if you like my video or not. And student, if you want me to make more videos on this topic, so please let me know by writing it in the comment section. Thank you students, and have a good day ahead.